So good evening, everyone. My name is Meralda, and I'm the co-founder of Emilio AI. And I'm just going to get some housekeeping out of the way. The session is scheduled for 1 hour, but we will leave the Zoom meeting open if you guys would like to continue with the discussion. Questions are always welcome because this is a fireside chat. So we would love everyone to pop the question in the chat, and you can either read it out yourself or we can read it out for you if you'd like. We want to make the session as interactive as possible. So obviously we would like to hear everybody's voice. And if you want, you can unmute yourself and talk when it is appropriate. The session is being recorded and is moderated. So please be respectful towards the speaker and your fellow participants. You will be kicked out if you do not abide by our code of conduct. And the session will be available on YouTube under the official CNCF community YouTube channel in the next 2 days. So we can get started. I was reading Office's State of South Africa's Developer Nation report just the other day, and one of the insights really stood out to me. And that is the most desired skills that the developers want to learn is in cloud native and in AI. Of course, there's like this whole big hype in the SA enterprise about cloud that started 5 years ago and AI just a little bit after that. But they're often discussed as two separate topics. My intuition is that most of the cloud engineers come from DevOps or infra background, which is from one side of the spectrum. And the AI specialists, such as data scientists and ML engineers, often sit on the other side of the spectrum. The skills that's required for these roles don't usually come from the same cohort of people. So when we're talking a lot about data science use cases, we often leave out the infrastructure component. And when we're talking about the cloud and DevOps use cases, we leave out the application component. And that really is quite unfortunate because the two wouldn't exist without each other. Today, we're going to bring these people together. So let's welcome our two panel speakers, Harry and Archie. We're going to start by introducing Archie. She is the practice lead at Synthesis, and she has recently received her PRN, so congrats to that. She's also a PhD fellow from MIT, but I'll hand the mic to Archie to introduce herself.
Cool, thanks, Meralda. So it just sounds cool, but it was a lot of hard work to get that PRN. So essentially, I am one of the practice leads from Synthesis, and what my day job is just to ensure that people are actually following the right data practices, ensuring that people are actually adequately using their solutions and ethically using their solutions to get data-driven decision-making at the end of the day, it's actually quite an interesting space to be in because everyone wants to go down that route. And having that benefit, we actually managed to encounter a lot of the software engineering side of things. DevOps is a huge component of it, so Harry will probably speak to that a lot. But essentially, we do need to be able to cross-collaborate quite often. So I'm actually quite excited for this fireside chat to see what everyone's views are in this world. Thanks.
Awesome, thanks for that. Harry is the co-founder of Emilio AI, and he's also the official CNCF ambassador in South Africa and Africa. So Harry, can you introduce yourself?
Yeah, sure. Yeah, thanks, Meralda, and thanks, Archie. Yeah, so not as cool as Archie. I don't have an awesome title like her. I'm just a co-founder at a company called Emilio AI, and what we specialize in is a practice called ML Ops. So like Meralda mentioned, what we focus on is how do we marry machine learning and DevOps together as a holistic solution. Personally, I'm from a software engineering background. I moved into the DevOps space about 5 years ago, and that's when I started my cloud native journey. And yeah, haven't been back ever since. I've just been continuing on this cloud native journey and spreading the good word. That's me.
Awesome. So we're going to get started about what does cloud native and data science have to do with each other. So there has been a lot of hype around these two different areas, and it seems like there's two separate definitions of cloud native data science. One is the normal cloud native, meaning for software engineering, so microservices, service mesh, and a lot of like Kubernetes stuff. and building microservices so that they can be more scalable. And the other definition of the cloud native seems to be using a lot of managed services from AWS or from Azure, so they are inherently on the cloud. And of course, there's two contradicting views, but neither of them is right or wrong. Maybe we can just start from really cloud instead of cloud native, and then we can move forward from there. Archie, can you give us an overview of some of the data projects that you worked with that are either hybrid cloud, single cloud, or multi-cloud?
Sure. And it's actually a very interesting question, because a lot of the times depending on the size of your environment that you're working on, you have to actually adjust and change. It's like goes back to traditional engineering, right? Where you fit a solution for the environment and not, funny enough, not for the actual debate. You would want to maybe like deploy a Kubernetes cluster in this environment, but realistically speaking, you need to consider the implications of the environment. So essentially you have to dabble between all these different areas. And a lot of the times, what I end up dabbling with is hybrid cloud solutions. So a hybrid cloud solution typically within the data field, and I think it's actually across different types of projects, but me personally, what I've had to deal with is having to work with on-premise databases and then potentially bringing that information back into the cloud and utilizing the cloud compute capability to create models. So a typical example would be maybe customer profiling, where you have all your customer data sitting on premise and you can't necessarily move all that information off the bat into the cloud environment, compliance, blah, blah. And we can probably speak about that a lot because that is a huge component. But essentially moving some of that information there anonymized and then utilizing cloud compute capability to build a model to give you a customer profiling solution at the end of the day. So, that's a typical example of having hybrid cloud. There's obviously tons more. Then something that has been single cloud for me it had nothing to do with the environment. Is specifically something that the environment of the client wanted to utilize AWS. So in that particular instance, it was just utilizing all the AWS services to do a full end-to-end solution. An example of this was a data lake solution. So where all the information was managed within the data lake environment, and then everything was processed in that specific environment. It never moved out. It never moved from a specific space into the space. Everything was managed in the single cloud environment, purely because of that's the way they wanted it to be. There was no particular reason for that. Then the other one is multi-cloud. And this is actually, I see this kind of being the next step of all of this, because I don't know if I need to convince anyone about the cloud in this particular instance. I think a lot of us here are inherently biased, which may or may not be a good thing. I don't know. But essentially, because let's just say we're all biased towards cloud, and we know that we have to eventually go down the cloud route, it is also essential and it is important to know that each cloud provider has their pros and cons. And sometimes you might find that utilizing one service from one particular cloud and using a service from another cloud helps you to get a better solution. And a typical example of this has actually been in the chatbot industry for me, where utilizing Lex from AWS and then utilizing the database storages from the Azure environment actually turned out to be more feasible, because the environment in which we were constructing this space was purely Azure driven. And we wanted to utilize Lex capabilities from AWS because that performed better in that particular context. So that's the difference that I'm seeing personally. There's obviously tons more use cases, but off the bat, that's what I can think of.
Okay, that's very interesting. It seems like you have quite a bit of experience in the different type of cloud construct, and it all really depends on what the use cases are, such as, for example, the PUPI compliance, and really they just want to keep in a single cloud and use the same managed service. Okay, cool. Harry, can you also give us a little bit of an overview of what is cloud computing, and what is cloud native? How does these three things link together from a CNCF kind of?
Yeah, sure. So I think I can start off with cloud. So just a continuation to what Archie was talking about, right? So cloud really started about 15 years ago, and it does bring a lot of benefits to people. And a lot of that is around sort of ease of use, and sort of you don't have to procure your own servers anymore. And that's the allure with cloud in general. And everyone knows that cloud is just someone else's computer. I mean, it's another server that you're using. It's not like you don't have a server. It still is a server, but you're just renting that server. And what a lot of companies like about that is that essentially you don't need a large team anymore. So traditionally you would have multiple teams managing multiple sort of facets of the entire software development lifecycle, right? So that goes from your infrastructure, your normal engineers maintaining actual data centers, all the way down to your network engineers, all the way down to all of your people who's actually doing the support and maintenance of OS updates, security patches, and all of that. And what cloud essentially does is sort of just abstract that away from you. So I mean, it's not like the network engineers or infrastructure engineers don't exist anymore, but yeah, they just work for AWS. So that's just cloud. And in terms of cloud computing, it really is sort of a set of practices or tools that the cloud provider actually gives you. So if you just do any certificates with any of the public cloud providers, you'll sort of just learn how to use these tools. And that computing portion is just basically the usage, how to use those servers, the cloud itself. What cloud native is, and people do have a lot of misconception about that, is that cloud native is actually not really that much to do with cloud per se, but around practices and just a culture around how do you actually sort of merge your teams, their organizational structure, as well as the culture. And this sort of set of practices is founded by CNCF, the foundation, which they just want to collect, like there's so many people doing different cool things out there. Can we actually just bring those practices together, form a set of best practices that everyone can reuse? So that's how the Cloud Native Computing Foundation started. But basically it is around 4 core components. So that's your DevOps, your microservices, containers, and then of course your continuous delivery. So, I mean, that's just throwing more buzzwords at trying to explain a buzzword, but essentially it's just a way to do things. And the official sort of definition of cloud native is actually on our CNCJ webpage. If you guys are interested, you can go have a look. It is quite confusing, but just everything just revolves around using containers and microservices with the DevOps culture, in order to actually give you continuous delivery. Wow, okay, I just use all 4 buzzwords in a single sentence. Okay, cool. But yeah, that's essentially
well
it.
Done. Cool. So now we know what the difference between cloud computing and cloud native computing is vaguely. Maybe we could start with like, what are some of the examples of how cloud really accelerated data science projects? Archie, can you give us some examples of why using cloud compared to before has really like make our data scientists work a little bit better, a little bit easier, or scales a lot more?
Yeah, actually, I'm still impressed with how many buzzwords you're able to use in one sentence, Harry, at this point. But so essentially, I think it's when we're to think about how cloud is beneficial just in general, right? It's from a scale perspective and from a bringing in more resources to the table and having more cross collaboration. It definitely does showcase that whole element. And I think and I hate having to use this, but I have to because it's still something that everyone will relate to. But essentially within this pandemic space, right, if we're to actually think about one of the reasons why we're able to come up with a vaccination so quickly, well, whether it works or not, we'll find out. But essentially, like one of the main reasons is actually the fact that we have such access. We have access to cloud computing. We are able to crunch numbers at such fast paces. We're able to collaborate across the country. These days, for example, if I do something here in South Africa, I'm able to easily pass that information to another country. And maybe in the past it wasn't so easy. Maybe it was, who knows? But like at this point, the fact that we have so much information and so much computation available to us just because of cloud is one of the big reasons why we're moving so fast as well. And I think even in terms of if we're to start looking at the machine learning models we build these days, and Meralda, probably Harry, I'm not sure if you know or not, but essentially like with the models we build these days as well, the amounts of data we can crunch, and this is and I'm going to go into a little bit of streaming world as well because it's relevant in this context, but the fact that we have cloud capability, the fact that we can actually crunch those numbers at those speed helps us to build better models as well. And remember, the one component that we always forget about machine learning models, or may not forget about machine learning models, is the fact that we need to bring in the feedback component, right? We have a model that is deployed out there, but we also need the ability to be able to repurpose that information coming in. We need to be able to crunch the numbers again and often, right? It's not just a case of being able to drop a model and then boom, that's it. We need to have the infrastructure capability to constantly recycle that information coming in and updating the parameters that we need to update at a fast enough pace. And that's actually the only way we're able to truly understand the effectiveness of a model. So that is made possible with cloud, because essentially you have all the infrastructure you need to be able to do that sort of fast-paced real-time interaction as well. And I spoke to the streaming component. That is also another thing that probably wasn't possible when cloud didn't exist. I actually can't even think of a world where cloud doesn't exist at this point. It's impossible for me to think of that. But essentially, being able to to build in like streaming capability, be able to bring in all the data that we need to at such paces. It's actually ridiculous how much information we have at our disposal at this point, and the fact that we're able to compute all that information at that fast pace, auto-scaling all of the infrastructure we have, so that people don't have to sit there managing things. Like, imagine the networking guys. Did they ever go home? Like, that's what I'm thinking about at this point. Did they ever actually go home? Did they ever have a life? Did the database guys ever have a life? Because a lot of it is now managed by cloud computing, right? And by cloud services in general. So I think I went in a rant there, but there's a lot of data projects that have actually had a better quality output as a result of having access to cloud services. And I think the vaccine rollout program is definitely one of them that we can all relate to at this point. But if you're just to look at your handheld device, at your cell phone at your disposal, everything is probably possible in there as a result of cloud computation.
Okay, that really sounds super awesome. So Archie, in summary, there is the whole reliability and scalability component that the cloud can give us, because we don't have to procure our on-premise server, so that we can actually run with these really, really big numbers in a very short amount of time without going through the whole procurement, finding network engineers. I don't know even where they sit right now. They all sit on AWS and Azure. But if it is so awesome, why do you think not all data science projects is on the cloud? What is the reason for that?
I think the biggest thing is fear, to be completely honest. There's probably lots of other reasons, but I think one of the biggest things that I've seen is the fear component. A lot of people are afraid, and we've seen this with AI in general, right? Now, and everyone sees the benefit of utilizing AI. Some people think about the Terminator when they think of AI, but the reality is that people are afraid to try out new things. And it's difficult because if you don't know what you're working with and you don't necessarily know the complete realm that you're working with, then you have that fear element to it. So I mean, a lot of the people that I've seen that are working on data science projects that haven't moved to the cloud, it's firstly because of fear, and then secondly, they've built an entire system that is working end to end. Why would they want to move? Right? It's a more a case of that until they're forced to move, they won't necessarily move. So I think that's the biggest component, the fear aspect of things, and also not knowing how to go about navigating this thing. Because like realistically speaking, it is a paradigm shift, right? And you guys would all know, if you've ever had to move a completely on-prem driven organization into the cloud, it's actually a process. It requires a lot of just people, from a people perspective, from an infrastructure perspective. There's so much movement that needs to happen, and all of this needs to happen in parallel. So you can imagine the complexity around that. So I think a lot of it is the fear and not knowing how to go about doing something like that.
Okay, so do you think it's really because in a lot of organizations I work with, there's also a lot of people who are super driven and really want to do cloud. And I think a lot of data scientists and data engineers actually want to adopt that technology, but it's more that the compliance and your POPI regulatory requirements and a lot of these super necessary, but sometimes a little bit bureaucratic processes that are slowing things down. Yeah. So how did the software world actually adopt the cloud so easily compared to the data world? And is there something that we can learn from that process? maybe Harry, you can give your 2 cents since you're like this whole DevOps evangelist and cloud engineer.
Yeah, so like you said, so from my personal experience as well working with clients, is that from a software engineering world, they're more advanced. I mean, if you speak cloud to any software engineer, like, yeah, everyone wants to use cloud, right? But if you speak cloud to a lot of sort of from a business perspective, especially corporates or the more old school kind of businesses, there is this weird stance of, I don't know if you guys know about the not invented here stance. So it's basically, it's like you don't trust things that are that you don't build yourself, right? But I think it does have something to do with governance, compliance, and you want to be in a position that you have total control of your own things, right? So that you know where things are, who you should call to deal with it. The problem with these corporates that have this is that they don't believe in something like SLAs, SLIs, right? So it's like even if someone gives me 99% SLA, I still don't really trust them. So I think back to what Archie was saying, it is that fear, right? It is that we don't know what is going on because we too far removed from this new tech. I call it new tech. Cloud is the new tech, right? So we don't know what's happening in the cloud. We don't know what's happening in other people's servers. We have been doing this for the past 20 years. Everything's working fine. Let's just stay where we are. So yeah, that's my 2 cents.
So obviously you have been involved in a lot of transformational type of projects where you're like pushing the whole DevOps culture. Is there like maybe 1 or 2 anecdotes that you can give to the cloud, well, the data science community who really do want to move into cloud? Either of you can answer. Okay, I'm gonna pick on Archie because
yeah. So like I said, I think okay, this is Archie going. You can go first, Archie.
This is so much confusion. What was the question? Oh, DevOpsy type things that data science people can leverage off. Okay, so essentially, for me personally, and I could be completely biased because I'm very much in the data side of things, and I am to a degree, I am removed from the DevOps side of things. I go to people like Harry to help me if I need assistance around DevOpsy type things. But essentially, for me, it's don't underestimate the power of traditional software engineering when you're going into data science, right? Like when we're going to the realm of data science, do remember that, this is a product. This is a system at the end of the day. And because this is a product and a system, and you're so entrenched in the data science side of things, don't forget that there is a secondary component of it where you need to build out your CI/CD pipelines. You need to ensure that your software-based practices are in place. Like, don't forget about that. That whole component is just as important as building a BOM models as well. Like you really do need to incorporate every single thing. And so don't forget about the traditional software engineering thing. So, I mean, personally speaking, my background is also from a software engineering side of thing. And I think that's kind of what helped me in the data science side of data science world. So what I would tell a lot of the data scientists out there is, just because you're in the field of data science, don't think now all of a sudden that software engineering best practices don't apply to you. It's still very much important to you to ensure your software-based practices are in place. I mean, even things like clean code is very, very important in data science. Just because you're working in a little SageMaker notebook or a Jupyter notebook doesn't necessarily mean that no one else needs to pick that up and then take it into a containerized solution at the end of the day and needs to go through a whole CI/CD pipeline. So definitely incorporate software engineering practices into your data science so that in the long run, you do have a sustainable solution. Yeah, that's my 2 cents.
Yeah, that's actually a very good summary, because a lot of the times we tell people that in software engineering, you version your code, but in the data world, you version your code, data, and model. So how can you not adopt best software engineering practices? Okay, cool. So I think we've delved enough into cloud. Maybe, Harry, you can give us some examples of what do you see people using cloud native technologies in data science projects? Or is that still like something that's completely new? Okay.
So I think in the South Africa context, it is quite new, because I think just going back to what Archie was saying, that you probably do need to know a little bit about software engineering, being a data scientist. And what people normally think is like, if I'm a data scientist, I only need to look at my data scientist. I'm gonna, after I've produced my models, that sort of thing, a software engineer or a data engineer will come and deal with it, right? But then that sort of thinking is what is sort of what is actually creating little silos, right? Kind of like why DevOps came about was because there's silos between developers and operations team. And these silos will start to form when data scientists only care about building the best model, but neglect the good software engineering practices, like you mentioned, like versioning your code, model, and data. So I think the first thing is to somehow bridge that gap, get data scientists involved, and sort of maybe just introduce them to using containers. I mean, that's the first step to using any cloud native technology is build a few Docker images, and then we can go from there. But that step needs to be taken before anything significant can be done.
Cool. I know that when I first started dealing with containers, I thought I wrote this super awesome Docker file, and then I gave it to Harry, and he like ripped this whole thing apart. He was like, "Why is your container 7 gigs big?" And I'm like, "Well, I want everything in it." But it's besides the point. Archie, maybe you can give us some examples of, do you see people using cloud native technologies in data science projects? And what are the cool things that you're seeing in the industry right now?
I lost half of that question. Could you repeat it? Sorry, my internet died in that moment.
No problem. I actually hope I remember that question. But what I'm trying to ask is, do you also see people using cloud native technologies in data science projects? And what is the cool trend in the data science community right now in South Africa, or maybe abroad? Because we know we often lag a little bit.
Yeah. So I mean, at the moment, I have to give the community a lot of props here, right? I feel that somehow we're kind of getting to a point where South Africa and internationally we're kind of in alignment. There is like a lot of overlap that I do see over time. There is obviously there is still a bit of a gap, but we do tend to follow the same sort of trend. And there is a lot of emphasis, and I'm so happy about this. I'm so happy about this. There's a lot of emphasis on ML engineering, right? Like that is a huge component. Like previously, the unicorn was data scientists and being able to crunch data. And then people have now started realizing a little bit more about, it's not just about being able to look at the data itself, but also being able to look at the whole end-to-end solution. So I can't give like one specific tool because there's tons of them out there. So there is a lot of emphasis on ML engineering type, ML ops even type solutions. So Kubeflow, your SageMaker pipelines. I mean, if you're to actually, I don't know if you guys saw the AWS reInvent in December last year. So essentially there was like the SageMaker notebook has actually just completely transformed into a full ML engineering pipeline being well managed across the domain. So that is a huge trend. So every single, I think from a cloud perspective, there's a lot of tools now that people can utilize to emphasize their ML engineering stacks. And another huge one, which I'm also pretty happy about, is streaming. So streaming is also a huge component these days. A lot of people are getting into that realm quite a lot because, real-time information, we need to do things quick. So Kafka's, the Kinesis, there's a lot of them, right? And they tend to be going down that route a lot more. So, which I'm very happy about. I'm very happy about all these things because we seem to be going in that same direction. Overseas, what I am seeing is, so here in South Africa, we're trying to get, depending on the corporate size and all of that stuff. But like I see a lot of the startups adopting a lot of these new technologies quite quickly, which is great. Corporates is still kind of like picking up in terms of the stacks. But essentially they are all adopting cloud. It does look like everyone is going down the cloud route, whether they decide to go the AWS route or the Azure route. There is like pretty much, it depends on your pick at the end of the day. And then overseas, what I'm seeing is people are now getting a little bit more conservative, which is a funny direction. People are getting a little bit more conservative in terms of data sharing. And now they're going down the whole fed learning route, right? Where it's now a case of how can we actually build models utilizing a fed learning approach rather than using a traditional ML engineering approach because of all these data privacy concerns. So there is like a bit of a difference. And I think people are trying to go in that direction because data privacy and security has become such a huge thing. I mean, if any of you seen the WhatsApp debacle, you probably would know where all of that is going. So that's the trends I'm seeing these days.
Okay, yeah, I definitely seen the WhatsApp debacle because my Telegram is just now flooded with new joiners. But,
Yeah.
so the cloud native world in the software engineering world is like building these microservices, and it kind of is, I'm not sure if it is easier, or maybe it just started from that direction where you have like very well-defined declarative APIs and things can be standalone, and you can scale your back end and front end like completely separately with your database completely separately. How does this work for a data science or machine learning pipeline, or even just actually data projects? Harry, do you want to give your 2 cents?
Yeah, sure. So I think using microservices in a data world is a little bit different to microservices in a software engineering project, right? And I think the main thing is about the handling of data. So microservices in software engineering, you're able to, like you mentioned, separate data. So each microservice is a custodian to its own data, right? So there's no such thing as data sharing, the database sharing, because you would speak to the application itself in order to retrieve that data. So that's a normal, typical microservice design, right? And then they try and sort of shy away from having a single database, but lots of application sharing, because that causes a lot of issues, especially if you have, like, let's say, 160 microservices and a single database. That schema change of one service affecting all of the other services is a huge problem. But in the data science world, that is required, right? Because when you do your multi-step analysis, each analysis you can't expect it to have a separate data, right? Because it's sequential. It's like you would have to go from step one when you do your EDA to the next step. The next step relies on the results of the first step. So it's actually not practical to maybe even just make a copy of the data, because we're not talking about like 1 gig, 2 gigs. We're talking about like terabytes or even to petabytes here. So that's the challenge with using microservice architecture in the data world, is that how do you actually share data between your multi-step process? And I mean, there are ways to do that. You can do maybe data versioning if you just want to make sure. You can revert some data if your step goes wrong, because you are actually sharing data. And there are ways to also structure it if you want to go microservice. And microservice normally are separated depending on your business domain, right? So it's a lot of like domain or driven design around that in order to find your boundary context. And you can sort of apply the similar approach to data science projects. Yeah.
Archie, do you perhaps also have some experience on how would you design something that is maybe a traditional ML project to something that could be a little bit cloud native? You don't have to go too deep into detail because we will unpack that a little bit, maybe just on a high level.
Yeah, so that's a very good question, because I've had to do that quite a lot. And so, okay, I'm going to go high level. So it starts off with essentially being able to understand all the touch points, right? So understanding in your ML engineering or ML projects, what are all the touch points that you have? Whether it be on-premise services, whether it be within your internal containers as well, what are the different touch points first? So isolating that first, understanding what are the different risks associated to each. I know this is going down systems engineering, but that's essentially the same route we have to use, understanding the different risks that are associated to each of these different domains. Then once you've I completely understood what is the full extent of your project, and you'd like to translate this into a cloud native solution, then the next step is to actually look at like for likes. So start looking at the functional designs, start looking at the functional components that you would need to translate into a cloud native solution. And then once you do start isolating specific technologies that you would like to pick up on, then the next step is to understand, is this technology that you're picking that is cloud native actually a feasible approach, right? Once you've actually isolated them, that is actually a lot more people and process orientated than anything else. Is your company actually well suited to be able to adopt this next cloud native technology or not? Is your domain actually ready to handle the scalability? That's funny enough. That's always a big one that comes up. Is it scalable enough? Are you sure that there are the adequate SLAs in place in case of a downtime, or whatever the case may be? So then there's a lot of those components that you need to cater for. And then only once you've done all of that, can you actually get into the domain of the data aspects of things, and now understanding, cool, now that I've kind of got an understanding of what my solution can look like cloud native, what data sets do I need? And that's usually when the huge blocker is. But now it's about understanding the different data sets that you require. What are the categorizations of the data? Once you have the categorizations of the data, you need to ensure that you are complying to the different standards, the GDPRs, the POPIs, all of that. And you need to ensure that you have a game plan for each of these different sensitivities. And ensure that you are complying with all the necessary security measures you need to. And then you finally go into architectural approval and eventually build it out. This takes quite some time, as you can hear, but essentially I'm probably missing a ton of steps in between, but those are the key ones.
Okay, that's a very comprehensive overview, actually. I really like that you say start from the high level architecture, because or the system design, because as engineers, you kind of have to draw out the whole picture and then start isolating these components instead of, oh, I know I need streaming, so I'm going to go with kinesis, and then completely kind of flip that process around, right? So I think that's a very good approach that you take. And I hope everybody adopts that approach, because that is good engineering principle and good engineering design. But when do you think that, obviously there are use cases, at least from the traditional software engineering world, that there's like this microservice is a new thing, but then all of a sudden there's like this whole, oh, you shouldn't do microservice for everything because sometimes it really is an overkill. Is there like a line for that for data science? Maybe Harry, you can start with this question first. Like, when does it not make sense?
So I think it starts with the software projects, right? So like, when does it not make sense for a software project to use microservices? And funny enough, it would be if you're a startup, right? So the thing with startup is that your realm is always changing, right? Because startups, follow the lean startup principle, and you want to like do things, and you want to experiment with things, you want to test things, and a lot of the code that you create as a startup, you would actually throw away majority of the time, right? If you start off by doing microservices, right? If you start off designing your application already, like, you don't even know what your product is yet, because you actually want to test it. And you started like, breaking it down to, okay, cool, I'm going to have a payment system, I'm going to have this, user system, and then they're going to be different microservices, they're going to call each other. You're going to run into a situation where, your assumptions are wrong, and you have to come back and you have to deal with it. And microservices, I mean, the whole point of it, in order to not cause any complexity, is that bounded context. And a lot of the times, we see that, people who actually start off, a brand new project with microservices kind of land in a position where they have this weird Frankenstein's monster of like things that are just having like leaked bounded context to each other. You realize that, okay, this is that very, very complicated way of doing it. And then you actually land up with this major overhead of maintaining this microservice architecture, whereas it could have just been avoided by just using a monolith, a single massive program that deals with payments and user management. So that's from software engineering. Like when we see like a brand new project, you shouldn't go for microservice. Microservice should actually be the last resort. So when you've already actually know what your domain is, when you actually sort of already figured out that, okay, cool, payments and users should be separate, it makes sense. You already know what that bounded context is, then you start to do that. So a lot of advice that I normally give is, start simple, start building everything in a single instance, and then until you can't scale anymore, then you find out which components require scaling, and then start to design, from domain perspective, what these bounded contexts should be, and then start to extract that monolith into microservices. So in the data science world, when would a sort of microservice sort of not make sense is, for example, if you're just doing, again, a brand new project, just doing your EDA, right? And the next is like, cool, I'm gonna train a model, I'm gonna deploy it. Your model itself It just needs to be a simple inference. It doesn't need, you don't have to break it down in several stages of like, my API is going to be very, very different to how I'm going to grab the model and then where I'm going to host the model. You can just, put it into a Docker image and just put it out there just to test. Just because your feedback is a lot faster. You want to, as a brand new project, you want to reduce that overhead as much as possible until that overhead is unbearable. And then you start thinking about using like cool technologies, cool tools. So my advice would be like, maybe start with the basics, just get it out there first, and then worry about a lot of these microservice architecture design, fancy stuff later.
Okay, that's very interesting because a lot of the times people always think that, oh, this is the new shiny thing. And if everybody is doing it, I must do it. But there are a lot of times when it doesn't make sense. And that's especially true when you're just starting something new. But from my own personal experience with like a lot of data science projects, you never know what you're trying to do. I don't know, Archie, if you can attest, but what you started with your EDA, you have all of these assumptions, and to the model that you're going to build, like this is, oh, I want to use TensorFlow 3.0 because it's like the coolest thing. And then you're like, oh yeah, I actually built a linear regression. So
happens way too often. I'm not
Archie,
proud.
yeah. Archie, do you actually have some experience of you took a project, you build it in like however engineering way that is feasible for that moment, and then had to re-architect it? What are the steps that you had to go through, and what are your anecdotal advice?
It happens way too often, Merelda, to be honest, and I'm really not proud of it. Because you don't know, right? It's this whole agile methodology type thing that we're doing. It's, if we had waterfall, it'd be great. But it's not the case. So like if we are going to go quickly and if we are going to fail fast, we have to go down this route. And you definitely do need to fail, which is quite sad. I had to eventually come to terms with it, but you do have to fail to realize what is your technology of choice. Something that has helped me, and I used to suck at this previously, right? Because I was very much just trying to build whatever's the new shiny tool in the and like, this is the new cool thing that's out there. Let's try it. So I kind of introspected a bit after going down the route and realizing, this is not working for me, because picking the new thing that I'm seeing is not really the right way to go about doing it. So what I do now is I actually utilize something that is more stable. So as opposed to actually diving into something that is new, I actually utilize something that's more stable, get the relevant, especially if it's like Harry was spot on with regards to like, startups should like be as conservative as possible, because especially if you're trying to prove something, it doesn't make sense to dive into something that's new and completely unknown and then having to prove your business proposition at the end of the day. So rather stick with something that has a little bit more stability to it. I'm not speaking specific to packages, right? Like is pick things that are more stable, pick things that have been utilized in the past, because then you have Stack Overflow that comes to the rescue. So essentially, then you have everything you need, right? So if that is your domain, then it's try and stick to the stable components. And then go forward with that. But I think it's important to prove that end-to-end value, even if it is with your with the smaller components. It is important to prove that end-to-end value. So try and mitigate the risk by sticking to more stable packages and sticking to more stable software. And then if it is something that's more in the R&D space and you do have the capability or the ability to fail and you actually are just supposed to trial out the software, then by all means, go for it, because in that sort of particular instance, that is your main mandate. But if the product and the project is under time pressure and you need to prove something, try and go with something more stable. No one's going to judge you. No one's going to judge you for picking the easy option. You're trying to prove a concept here. And you guys do it really well with this whole CJ stuff, right? You have all these necessary principles that you should follow. You have all the documentation in place, and people have something to look back at. There's a group of people that you can refer to. So go for technologies that have that support structure, because as much as engineers think they know everything, they don't. And you do require a community to help you to build something going forward. So try and stick to those sort of technology stacks rather than diving into something that's completely new and you have no one to support you through that journey, especially if you're trying to work on a project from scratch.
Okay. That's actually a very like confidence boosting that I'm not the only person who's always flailing around Stack Overflow. Be like, I don't know what I'm doing.
Oh, Stack Overflow is my best friend. It's my best friend.
Yeah.
Yes.
Cool.
Google
So
and Stack.
Harry, you also have Harry, you also have quite a bit of example of like re-architecting things from like a monolithic to a microservice way. Can you think of how you would do that in some of the data science projects that we have worked with, and maybe your experiences of what to do and maybe what not to do?
Yeah. So I think in that sense, you should, like Archie mentioned, use something that is stable, right? Especially if you're just starting out. And if you want to start out with a data science project, there are projects out there that's already end-to-end, right? So it can either be AWS's managed service, you can take it, you use their managed services, they will actually provide you with their own well-architected framework on how to actually build a model and deploy it. So you can even go down that route. If you don't want to use sort of managed services, you can of course build your own. There is a very popular project out there, Kubeflow, which we use quite extensively, just because it's not really tied into any cloud provider, right? As long as you have a Kubernetes cluster, you can use it. And but then besides Kubeflow, there's other projects like MLflow. Even sometimes you can use some components using Airflow if you want to use a much simpler tool. So I think technologies are out there that you can just reuse. You don't have to like build from scratch, and they are quite stable, just the tools that I've just mentioned. So yeah, I think that's what you should start off with, using stable technology.
Cool.
Recommended by CNCF.
Kubeflow is finally stable, right? Because I remember that day when we tried to do a demo and then push a new update 2 days before and we forgot to version pin. That was a disaster.
Oh yeah.
So
Although that's us not following software engineering practices. Always version.
Guys, we just had a talk. Come on.
So we got a question here from Jay Shill, and he said, maybe Jay Shill, if you don't mind, do you want to unmute yourself and ask the question?
Yes, we want to hear voices.
Sure, no problem. Yeah, it's just a question. I mean, I think Harry's answered it already. It's you quite often, like Archana mentioned, I think the cloud managed services, I mean, they give a much better user experience. And like from personal experience, I've noticed that trying to manage Kubernetes clusters and DevOps and logging frameworks and all of that, you end up doing more time doing DevOps than actually doing work. So it's just like, so it's, for me, I think a takeaway is, like you said, Kubeflow is now stable. So look into that. But yeah, I mean, it's the same thing what you mentioned, like you working with some technology and an update comes up, and if you're managing it yourself and then next minute it's not working. So that's one of the disadvantages I just see with when you're doing things very natively and not using the vendor managed solutions. But then obviously it comes at a big cost. And like, I don't know if there's any like guidelines or how you would make a change in technology to a more cloud native based on cost. Like when does that usually happen? Or is usually the model already like changed so often that it's just better to use the vendor specific solutions?
Yeah.
Yeah, so
So,
you
so
unmute
Jisha,
yourself.
I think.
Go ahead.
Yeah. Okay. Yeah. So yeah, just want to add to that, Jisha. I think you're right. The thing is, like, it's very difficult these days to justify not using a managed service, because, like you said, you might need an entire team of DevOps engineers that can teach you how to use, some of these bespoke tools, rather than just use something that is already provided by AWS. And what we like to think about it is we normally give a hybrid solution. So depending on the appetites of the clients in terms of how much control they want themselves, kind of like when you have, infrastructure as a service versus platform as a service versus software as a service, you have those different layers which you have to manage yourself. So if they don't have the capability themselves to manage, Kubernetes, then yeah, by all means, use something that is managed by AWS. But if you do, and you have a very strong customization layer, then you should use Kubernetes and use Kubeflow. So it really depends on the appetite of your organization, and like if you really have the capability. Because the cloud, the biggest benefit of cloud is, you can do a lot of things with just 1 or 2 people, compared to what you could do 20 years ago, where like, you want to just, create a website or an e-commerce website, you need like, 5, 6 people. But nowadays you just need 1 person, and then they don't even have to own a server. They can just like, do things. You can even like use AWS for free, just like with Lambda functions, S3 bucket, like you can do a lot of things for free. So that's like, you don't need people, you don't even need a large budget to achieve what you want to achieve.
Cool. And I think maybe just from my understanding that because CNCJ has a bunch of projects, and these projects goes from like, I can't really remember exactly what the stages are, like baby, incubation, graduate or something. So to Harry and Archie's point, maybe pick something off the CNC project list that you will know it's definitely cloud native, and pick something that has graduated. Maybe that is a good place to start. Maybe Archie?
Yeah, and I really like the question, Jaishal, because it's something that everyone encounters, right? Like we would think we have a solution by now, but the reality is every single organization is extremely different, and their constraints are always very, very different from one to another. I can give you an example. So one of the projects that I'm working on currently went down the route of only picking managed services, right? They were like, we're going to go down this managed service route, and that is all we're doing. It doesn't matter what you guys think, we're just going to go down this route. And then it got to a point where it was like the managed service wasn't enough, right? The customizability within the EKS cluster wasn't enough for them, and they needed to actually go down that route. But the point is, they actually had to go on that journey, right? So from a cost perspective, they were aware of everything that is necessary, and they were aware of the cost that it had, the implications of cost. But they eventually realized that they need to go down the alternative route. So I think, to Meralda and to Harry's point, like literally you do just have to firstly do your research around it, see what's out there, see what is potentially good for your organization, and you won't actually know until you try it out. Which is, I wish I had a better solution for you, but every single organization is extremely complex, and it's not necessary to give a blanket statement for everything. But definitely do your research around it to see what could potentially work for the organization from a cost perspective, from an infrastructure perspective, and then go with it, try it out, and then see if you need to pivot from there on.
Yeah, okay. So it seems like Archie and Harry's advice are quite like in sync of really just fail fast and adapt. Cool. So I have another question here that really is just, now that Kubernetes is bleeding into data science, and it's just like a function of Kubernetes bleeding into everything, like edge devices, and Kubernetes bleeding into like blockchain, Kubernetes bleeding into banks. And what does that mean for data professionals? Does that mean that we now all have to become DevOps engineers, or do we all just, hire a DevOps engineer?
Okay, so I am very much of the opinion, this is just my opinion, this is not the be all and end all of everything. So my opinion is we should get away from trying to segregate what a data scientist does and what a DevOps engineer does. It's just something that I've found personally, and because if you're going to do that, then people will still keep working in silos. We're trying to get people out of these silos, because at the end of the day, if we want to have a good product end to end, we do require collaboration. And how is a data scientist supposed to know that you need to have CI/CD pipelines if they have no visibility on that, right? You can't throw it all over the wall and be like, okay, well, you deal with it at the end of the day. And the DevOps engineer sitting on the other side is going to be like, what are you giving me? I don't have any information or context to this. So I think to a degree, like, yes, have your specialists, but it's also important to have the knowledge, maybe not in-depth knowledge, but at least to a degree understand the full end-to-end process. And then if you require more help, then go to the specialist, but definitely have a combination of that knowledge set. So for me personally, I'm termed the ML engineer, but essentially it's a case of having software engineer and data science principles combined together. And that has helped me a lot. And I think just any data science professional, having the combination of that knowledge set is beneficial to yourself. Definitely have your DevOps engineers that can focus on the harder tech if it gets to that point, but also have the capability by yourself to be able to understand the full end-to-end solution. That's just my 2 cents.
No, that's really cool, Archie. And speaking from a person who is going after her PhD, right? Because usually we imagine PhD is like the super specialized, I only do like multi-agent reinforcement learning, multi-path, blah, 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 that kind of stuff. I know you're doing federated learning, but that's just as specialized in my mind. So it's really cool that you are encouraging everybody to actually dabble a little bit on everything. Do you feel like that has helped you professionally?
Definitely. It definitely has. I think having the visibility of all the different domains. I mean, sometimes, a big component that I'm pushing for is the healthcare sector, right? And I even sometimes dabble into into doctor spaces and into healthcare spaces themselves and I'm an engineer, I'm in the complete opposite spectrum. Having an understanding of that space helps me to build a better solution. And this is the same for in the financial industry. You need to have some sort of, and I'm not talking just from an engineering point of view, but even just in terms of understanding the domain in which you're working in, it definitely helps in creating better solutions.
Okay, cool. Harry, what is your experience like working with data science solutions where there really isn't, I don't know. Do you think data scientists should learn Kubernetes, or are they coming for your job? You should just do your job, be a DevOps engineer.
Yeah, I think to what Archana was saying, yeah, everyone should be like a cross-functional sort of person, right? It's like we keep hearing everyone should be T-shaped. You should know a little bit about the things that concerns you, besides your own specialty, your own expertise. So I fully agree with that. And so I don't think data scientists need to learn Kubernetes, because how long is a piece of string? You can always learn everything, oh yeah, data scientist plus DevOps plus infrastructure person and equals a unicorn or something. I don't know. But the reality is time is finite, right? I mean, it's not practical for someone to know everything, even the entire end to end. So you need people who are specialists in their own realm. But in order for that wall to break down, right, and that people don't operate in silos and better communicate with each other, you need some sort of knowledge about what the other person does. Okay, so I think that's what a cross-functional team should be, and data science teams should just be full of people who are cross-functional. But I think these days, well, having said that, these days, data scientists shouldn't be expected to learn Kubernetes, but they should be expected to learn a little bit about maybe containers, how to use Docker, even just the core concepts. And the reason for saying that is because if you think back, 20 years ago, being a Java developer is quite hard, right? Because there aren't, compared to nowadays, because there aren't a lot of frameworks or libraries that you can use. You probably have to write everything yourself. And like we said, time is finite. So you can only focus on one thing. But as technology is sort of mature and becomes more commoditized, people are sort of freed up to actually learn more things, and which is a good thing, right? Because then you start to broaden your horizon and you start to develop yourself and you start to innovate, right? Because that's just how innovation works. But as a data scientist, if with all of these data science tools becoming more and more of a commodity, such as AutoML and that sort of thing, it actually does free up the data scientist's time to learn about some of the technologies that concerns them, software engineering practices, maybe be a coder who does, like Archie said, clean code stuff, and just even a little bit of CI/CD and automation. Yeah. Also, my opinion, like Archie, my opinion.
We have a sample size of 2. That's good enough for now. I see that we have run out of time, and I don't think there's any more questions. So we will, as we say, we'll leave this thing open. If you want to chat anything, ask our presenter anything, you can just unmute and put yourself on video. Otherwise, our meetup has officially ended. Thank you, everyone, for joining.
Yeah. So I think we can open the floor up to people who want to ask. Ah, there we go. Yep, Nessa.
Yeah, how's it?
How's it?
Yeah, my question is should everybody so from the question I was asked about everybody learning data science, so my question is sort of the opposite. Should everybody just all the developers including DevOps learn data science since now a lot of things are data driven? So should we start learning data science? Or is it an overkill? So should we get the data scientists to do everything for us?
I like that. I mean, if data scientists expect to be DevOps engineers, why not do the reverse, right? Harry, do you want to go be a data scientist now?
Yeah. So I'm a T-shaped person. I know just enough. I don't need to know more than I need to. Yeah, Nicholas, you've just opened up a can of worms. But I think essentially, from my personal opinion, from my point of view, data is at the core of everything, right? When we talk about compute, what are you computing? Computing data, transforming data. Okay, when you talk about storage, what are you storing? You're storing data. When you talk about like the presentation layer, what are you presenting? You're presenting data. So data is at the core of everything, even like from infrastructure perspective, from a networking perspective, that data and packets flows in and out, it's all data. So from that perspective, then yeah, you should know a little bit about data as a software engineer or a DevOps engineer. But data science itself is quite a little bit different, right? It's not just data at its raw form. It's more than that. It's a lot to do with analysis and that sort of thing. And to be honest, I really don't think that should be the responsibility of a DevOps engineer. You should know just enough. Yeah, but maybe we should like draw out a spectrum, from like the infrastructure or the machine layer all the way to business, and then you'll see like which sort of cross-functional teams you should like work with, or what sort of skills you should get. I think that'll be useful. We should do that.
And I think even like from a
sorry.
Go for it, Merelda. Go for it.
Yeah, I just think that it's quite interesting because I am also not a data scientist from the beginning. I'm like some random consultant who draw blocks, but because of the things I do at work, we also promote like this thing of just-in-time learning, that if you come across things that you have to use data, then you learn it. It's pretty much the same as if you come across a new framework, you learn it. And it's not like you have to get a PhD like Archie to be a data scientist. It's
far away.
More just being able to communicate, and like if you do work in a data project with a data scientist, you will rub off some of these things. And I think it's more important that you have an interest and you gravitate towards that, then it becomes more like a fun thing to do rather than a job. And really, like, our job is really hard, and you don't have to give yourself more things that you're completely uninterested because the industry is moving one way, right? Although everybody should learn data science.
Everyone should be a data scientist. That's the moral of the story. But I think it's some valid points, right? I think definitely it is important to I think it's important to be open-minded. And this is like more than just being open-minded to new tech, but it's also open-minded to, like, if you're working in a cross-collaborative team, it's important to have an understanding of how difficult something could potentially be in the data science world, in the data engineering world, in the DevOps world. It kind of like helps you to build that a nice interpersonal relationship with these people and be able to understand how difficult something could potentially be. And by understanding the difficulty, you could potentially make their lives easier. Like, I think from that perspective, it is kind of important to have an understanding of how complex something could potentially be, just so that you could actually help each other out, right? Like, if I, like, from a data engineering perspective, if I ensure that my data is structured in a specific format and ensure that all the pipelines are working, then the data scientist at the end of the day that has to consume that requires less data cleaning in the long run, right? So that is also one of the constructs. Similarly, for a DevOps engineer that has to pick up something that an ML engineer builds up, if everything is well constructed in a good container and they can actually push that into a production environment without having to struggle too much, then makes their life easier. So I think from that perspective, it is important to kind of have an understanding of what it is that entails each person's job, just so that you can help them potentially. And yeah, from that perspective, I think definitely, but it is still difficult to, you need to kind of ensure that you don't take on too much. You've got already enough specialist roles as it is, just so that we can collaborate better, I think.
Yeah, that's really cool. I wish everybody actually operates that way.
We can only try. We can only try.
Yeah. So I see there's
So are you guys
still like a
okay
lot of
with,
people
like,
on this call.
are you guys okay with, like, you
everybody's
know,
just
having more and
listening to us
more citizen data scientists? I know it's like taboo to even talk about it in front of data scientists, to talk about the citizen data scientists. But you know, from what we're saying, you know, is it okay to have like people who know just a little bit, because it's the interest about data science, to just like know just in that?
Yeah, I think from my background, right, because I was also not a data scientist, and then I moved and studied my way to become more specialized. And there's like so many tools out there, like AutoML, like all of these platform tools that really make business people's lives a lot easier to become a data scientist. But there's the good and bad. The good is obviously everybody can like empower themselves, and data scientists can go and build like super deep neural networks rather than like doing SQL query extracts. But the other downside is the Dunning-Kruger effect of, if I only know this much, I don't know the rest, then it's very scary to build a model that you don't know how to improve, you don't know how it works, you don't know how to debug, you don't know if it's working or not working, and you don't know what data to collect. If your data is clean, then all of that actually perpetuates a whole negative cycle of dirty data, dirty model, really bad decisions. So I think citizen data scientist as a concept is really great, and everybody should, if they want to, should be empowered and encouraged to go on that route. But more just read a little bit more, be aware that there are all of these things that you need to actually build something that is effective, and you can stand behind your solution and say, this is how it works, and I can explain it very well, and I know how to defend it if it fails over. I don't know, Archie, how do you feel about citizen data scientists?
No, I think I'm pretty much in the same thing, right? Because we can't get away from being a specialist. You do require specialists in certain instances. Like actually, most instances you do require specialists. Whether you're a citizen data scientist or you're a DevOps engineer, at the end of the day, you do need these guys with their bazookas to come to the forum and help in situations like that. Because if every single problem was easy enough to solve for, then we wouldn't need these specialists. But the reality is that we have such complex problems that we need to solve for, and we do require specialists to come to the forum. And it's not as easy as just utilizing a managed service. Maybe most of the time, it's maybe not as simple as using a managed service or using AutoML, like you've mentioned. And you do require a little bit more speciality around it. And there's nothing wrong with that. There's nothing wrong with having a specialist interest, because it just means that is your interest. It's just important to be aware of everything else that's out there, so that if you are choosing an interest, it's well informed, and you can sort of see how it all fits in.
Okay, so I think we still have like 14 people on the call. I'm not sure everybody is just like really enjoying us three ranting away, or if there's like a really deep burning question that you want to ask, but are like a little bit too shy.
Yes, Meralda. No, not too shy. We're still here. Hi, great talk. I'm Brandon, by the way. Just from the perspective, the question that I have, or that's kind of like burning inside me, is so we're talking a lot about data science and some DevOps type work, and there's also this other aspect of, once you've got something that's up, it's running, it's maybe a product that a customer is using. How do you ensure that this product is fully available, meeting the right SLAs, targets, and how do you know that it's actually achieving its expected outcomes in terms of the data, the model, and that? So more of a monitoring side of things. And what would be your opinions on the term of like an SRE, site reliability engineer, in that sort of space? Just wanted to get your thoughts on that.
Cool, that's a really great question, and all delves onto like the back of ML ops. Archie, Harry, do you guys want to kick off?
I have tons of opinions on that. So, all the ideas just came into my head in one go and then disappeared. But essentially, it comes down to, let's start with the first thing, right? How do you actually ensure that your product is doing what it needs to do? What is your like acceptance criteria? Let's just use that term for now. What is your acceptance criteria to ensuring there is a success factor? So for me, and maybe you guys defer to that, but for me personally, it's more about the use case. It's use case driven. So I don't know if you guys have seen the ML lifecycle, and it's like, it's very much airy-fairy and it's up in the air, but I do actually use the ML lifecycle quite often because it is an iterative process. So after you have a model that is deployed into your solution, it's absolutely essential to go back and double check and make sure that you are meeting the business requirements that you started off with. It's more iterative, I think, in your ML engineering lifecycle rather than your software engineering life. It's still there in your software engineering lifecycle as well. But in your ML spaces in specific, you do have to constantly keep going back and looking at your business criteria to see if it is being met. It's absolutely important to choose the right data to ensure that you are actually collaborating with the right people that would need to consume this model outputs at the end of the day. And having that iterative feedback is absolutely essential. And it comes back to having your ML ops in place, right? If you don't have your ML ops in place, then how would you be able to get that feedback and to ensure that you are actually monitoring all the necessary success criteria for your model in the long run? I can't remember the next question, but maybe Harry, Meralda, if you guys have any more opinions. I know there was the SRE one, but you guys can speak and then I'll speak later.
Yeah, so I think Brandon is talking more specifically around once a model is deployed, it's in the wild, how do we make sure that it's performing well? And then perhaps, how do we actually monitor it? And maybe even taking it further as in, okay, my model is not performing well. How do you swap it out? How do you retrain? And I think based on what you're saying, Arch, totally agree. It really is on a per use case, because it's not like every single model is exactly the same. There are tools that help you with this. TensorFlow itself has TensorFlow board. You can monitor with using other open source technologies. So if you don't use TensorFlow, there's Seldon, which actually helps you with doing once a model is out there, well, what should you do? So they have their own best practices, but again, best practices should always be treated as sort of guideline, right? And then those guidelines are basically what you're talking about, ML ops. Meralda actually did a fantastic talk about ML ops in AI Expo last year, which actually incorporates, well, not exactly what you should be doing, but perhaps aspects that you should be watching out for. The 7 principles of ML ops. And I think the last 4 principles talks about what should you do when you want to swap out your model and that sort of thing. But maybe even deeper, maybe you should also consider maybe security as well as governance. Archie will know more about this type of stuff. She can talk more about it. Maybe differential, I don't know, learning, that sort of thing. But the thing with an SRE in this space, there's definitely a need, because at the end of the day, data science or machine learning models are not your traditional applications, right? So they're a little bit different, and the way you treat it is not okay, it's just API. They just deal with like any other application that offers an API. It's not like that, because there's actually more to it. And but yeah, if you're interested, we can send you Meralda's link and you can have a look at the 7 principles of ML ops.
Or you can go to mlops.org. But I think at least when I first start with a project of building a model and I know that it's going to get deployed, there's always that metric that you measure, right? So be it accuracy, be it F1 or whatever. And it's really good to measure it post-production. I know it's very difficult because obviously you worked with labeled data sets, and then you train it, and then everything starts coming in and all of these things are unlabeled and you don't have interns anymore. Then it can become difficult to figure out is my accuracy still at 90% because I don't have new labels coming in. How do I really like make sure that it's still at 90%? And I think like obviously relabeling, but also you can definitely track concept and data drift, right? You know what are the variables that are used, at least from like a lot of supervised learning perspective. You know the correlations, you know that this is what my sample size look like, this is my cohort. And if they start drifting, and they will drift, then you can at least pick it up and say to your business stakeholder or say to, I don't know, your junior data scientist that, hey, it's time that we start relabeling the stuff. And maybe it's time to rebuild a model or retrain, but always retrain. But yeah, I'm not sure if that helps. And if there are any other questions. And thanks, Brandon, for that.
So with this monitoring models, can we integrate them into the existing monitoring tools that we already know, or does it require some special tools to be able to monitor the models?
Yeah, so you can definitely use existing monitoring tools that you have available, you know, being Elasticsearch or any of the other monitoring tools that you might use, because it really is how you actually structure that's basically the metric that you're measuring. That is more important than the actual tool that is collecting the data, because I mean those tools are very specialized at collecting data, what you already have. I'm not sure what it is, but what you're doing is just interpreting that result and setting that metric. That is what you should be focusing.
Thank you everyone for joining, and we're really looking forward to the next one. If you have any questions, please pop it to Archie's email and Harry's email at harry@melio.ai. And let's hope everybody gets a t-shirt. Good evening and have a good weekend.